Hope you are able to see my screen.
Yes, Indra, we can see.
Okay, sure. So we'll make a start. So today's session, we are going to discuss about the serverless, right? So kind of like what is serverless, what is the difference between um, the traditional, the server-based approaches versus serverless as well, and what are the pros and cons, and what is AWS Lambda? So what is the advantage, and and also we'll try to do quick check on how we can develop something with AWS Lambda as well. So idea is that by the end of next 30 to 45 or 1 hour, I want you to kind of get an understanding of what is the serverless, the concept, and then especially what is AWS offering, AWS Lambda, and how we can use it. And probably this concept, it's also very important DevOps area as well, right? So development is all about the DevOps is all about automating, right? So it's one of the key philosophies, we automate things and we try to ensure that we reduce our the blast radius, we embrace some risk, right? So those are kind of good things which DevOps is bringing. So again, serverless is a one of a kind where it will go and actually help us to improve how we are doing our development and how we are looking at things outside the box and in a new way. And so serverless is very wonderful thing. Like if you are a developer, you're going to love it because so you probably will have more time to focus on your code than anything else, right? So that is kind of like the summary, right? So example, if someone asks me, explain to me serverless in kind of as I'm a 5-year-old, it's more of you just focus on development part, not to worry about the infrastructure or the environment and those things. Someone else will take care of that. So with that, the agenda is, as I said, that we will cover about what is serverless and difference between the server base and serverless, and we will get ourselves familiar with AWS Lambda, how Lambda is working, and touch upon some use cases and pros and cons, and then I'll try to give you kind of very basic examples, right? Where you can get familiar with the code and the structure and those things, and hopefully that that will allow you to take your journey, and then probably this will give you kind of a base where on top of this you can go and learn and and improve about this area. And like usual, feel free to interrupt me anytime, ask any question or anything, we can make it a little more interactive. So I think based on all our previous sessions, you already know that traditional development is kind of like this, right? So we kind of example regard if you take a web application, so we kind of look at uh, if you look at it from a very holistic way, we have our front end code. It can be Angular, Node.js, or like anything, right? Or PHP, anything. And then we can have our backend codes where which is our business logic. Typically, it can be microservices or any other thing. And then we pretty much have a database. Yeah, we actually have our the actual the data stored, right? So whenever users are accessing our site, what we have done is we have gone and deployed our front end code in server, and we'll have to ensure that we manage that front end code, and then it will make request to all to our backend code, and then backend code will internally up, insert or update or delete the data in the databases. So in some cases this can be like in a single server you have both front end, back end, databases likewise. But in other instance, you can separate that uh, the front end, back end, and database for more of a security purpose and to improve, provide more speed and those things, right? So I think if you remember some of these sessions, we discussed that advantage of segregation. So probably we can have a web server here, we can have application server here, we can introduce a lot of caching here, right? And we can limit some of the requests coming to the backend, and we can kind of have firewalls in bit that probably entire this set is kind of like a companies intranet or internal systems, right? So outsiders are not able to access directly, right? We can have better security. So there are a uh, advantages by going with this kind of a uh, tier based approach, right? But the other disadvantage is that probably if you are going with this kind of architecture, you will have to plan, and you have to uh, think about the infrastructure, right? So basically assume that very like previously, like probably this is my SQL database, right? So this is your kind of like uh, the PHP based code, or probably Python based microservice or something. Probably this is again, you might refer some PHP or something, and then you probably will deploy your HTTP server as well, right? So that stack is a very famous stack. But idea is that you will not only focus on creating the database, or creating your the backend code, or not only the front end code, but you will try to spend a lot of time on deploying these things as well, right? Probably if you are like nowadays there's a uh, major trend in the industry saying a full stack engineer, right? So when you say someone is a full stack engineer, there's a feeling that he might know end to end, right? He might know how to develop something in front end and develop something in the back end, and he might know something about the databases, and then put this everything together and deploy, and make sure it's working fine, right? So just to give you a heads up, it's again a very challenging role, and you will not find very skill, or you will not find many people that who will actually uh, who will actually uh, able to do this kind of work. But the idea is that it's again like there it's again an area where, like there's a new trend, right? But even with that, what the industry, or the customers, or the people who are working in this industry has identifies that it's still a lot of work, right? You can't expect a superhero, right? So that is a one challenge, right? So basically one of the approaches is to reduce this overhead of infrastructure, right? Because when I'm looking at infrastructure, it's not only just deploying the code, but I will have to make sure that I deploy the code, and I maintain this environment. And in case, like there's a spike of traffic, right? So assume that only 3 users are using, it's fine. But if it is 30,000, like it has gone increased, then I'll have to add more capacity to my server, right? CPU, memory, file system, and all those areas. Capacity is important, right? I'll have to do capacity upscaling, add more servers, clustering. So that is like a whole 9 yard of work, right? So that is a lot of overhead, and that is a lot of a challenge, right? So for one of the answers for this is serverless, right? So if you look at this comparison, so server based, we have to do this provisioning, managing the servers. We'll have to ensure that the capacity is being tracked, and the clusters and those things are our responsibility. We'll have to own the infrastructure, right? Patching, security, vulnerabilities, everything, and the continuous service cost, right? So assume that I'm a startup, I am using a server based system, but I have projection that things will grow regardless whether people will use my web the people will use my the website or not. I will have the server provision, and it's actually not incurring a lot of cost for me, right? Because even though there are 0 users are accessing my site, I'll incurring a cost because I'm owning the infrastructure, and I'm paying for that, right? So that is one of the biggest challenge, right, when it comes to server base, right? So regardless whether you used your the provision capacity, you will have to pay for the infrastructure, right? And there are, like the pros and cons, right? There are areas where you probably go with the server based approach, but in general, that that is still a you will upfront, you will have to make an investment, and get it done, right? So that's again a little bit of challenging, right? Serverless is that there's no upfront, right? So you just focus on your code, right? So the concept is you just simply code and let some infrastructure provider or like cloud provider or someone like AWS take care of the invocation part, right? So AWS will ensure that not the invocation but the infrastructure part, right? So we simply going to focus on our code only, right? So as long as we develop the code, we let the AWS or the other cloud provider to take care of infrastructure. So that this way, the cloud provider naturally handle the entire infrastructure, and we don't have to pay upfront, right? So we will pay only for the services we are using upfront. But if nobody is using my service, I don't have to pay at all, right? So this is a like a one big major advantage, right? So is that there's no upfront infra related cost, right? So we just simply focus on developing something and then we deployed it. Let the AWS or the cloud provider manage it, and then based on the number of requests coming in, based on the service being used, we pay, right, for AWS. So that is one major advantage, and there are a lot of companies using this, right? So one of the like one the company, right? If you have heard, there's the one educational company called Cloud Academy, right? So they are world famous for their cloud related trainings, right? So there are nice trainings and paid trainings as well. So when they started it, after some time, when the serverless was published, and when it was kind of even very new, they have gone into the serverless where they see a lot of benefit, right? So now they are only uh, like paying for what their customers are using. Right? Example, if you guys and myself are want to learn AWS, I going to Cloud Academy, I buy a account and then I log in. I'm viewing videos, then only they will pay, right? As long assuming no one is in the site, nobody is using the AWS and nobody is paying as well, right? So that's a very good commercial model, right? For any business. So again, nutshell, Service is like, we are owning the infrastructure, and then we have to own the every pane comes with the infrastructure as well. But serverless is that, there's no infrastructure, and we typically, go with the code, right? So our focus is only the code. So serverless computing is something like this, where we actually, I, like example, if it is myself, I actually write my front end code, and then I deployed. I probably write my backend code. I deploy. I probably use a managed database from a cloud provider, and then that's it, right? So the database is managed by cloud provider. I'm probably worrying only about the database. What are my tables? How I'm going to do some optimization, but scaling, capacity, everything will be taken care by the AWS or the cloud service provider. And I will simply focus on my front end code, back end code. I'm not going to worry about where it's been deployed, right? But I have a responsibility and obviously get these things working to set that what is that front end, and what is that, sorry, the runtime, and what are the dependencies, libraries, those things I had to do. But after that, the infrastructure is not my problem, right? If tomorrow I started this with the 3 users, but if tomorrow this become 3 million users coming into this site, is still that I'm not going to take the burden of the infrastructure, right? It will be fully handled by the cloud provider, but I will have to make sure that so initially they will limit my number of concurrent user count. So probably I'll have to I'll have to uh, figure out work with the cloud provider to increase the number of concurrent the invocations. So those things I will do, but apart from that apart from that, there'll be not much of a challenge for us, right? So we are fully focusing on our development, our kind of work, but and improving and giving a the quality system to users, and without worrying about the infrastructure. So that is the key benefit, that's the serverless is bringing. So when it comes to like serverless, like from the AWS perspective, we have something called AWS Lambda. So that is run code without thinking about cloud or think about the service or the cluster, right? That is their motto, right? So this is again, seamless, deployment, right? No infrastructure. So we don't have to worry about infrastructure provisioning, thinking about the nodes and clusters and capacity, scaling, right? Those are not our problem, right? Especially scaling, right? So if you are managing a production system, you will know is the capacity is a very important thing, right? Usually what happens is that either we will over provision, right? That way that I will have so much idle space, idle resources, uh, and I'm paying unnecessary, right? Otherwise what will happen is we will lower, like we will not provision enough when the business requirement, business need more capacity, we will have trouble, right? We will have trouble running, right? So example, especially this is true for when you are streaming services and and a lot of online gaming platforms, social like channels, news websites, right? So example, if you have a news website, like generally you will have a average number of users who are accessing the site, right? But assume that there's some emergency happen, there's a major breaking news, then everyone will come to the site and you will get a high demand, right? So at that time you will have to ensure that you are ready with how to support that, right? With your scaling solution, ability to provision new servers quickly, right? So many things, right? So scaling is again one of the major advantage, right? We are getting part of going with AWS Lambda, and then it's a cost efficient, so we are only going to pay what we're going to use, right? Assume that you guys come up with some new idea and you build something, and if you are deployed in in a like in a traditional way, regardless whether you are making money, you will have to spend a upfront cost for your infrastructure. Now you just have to focus on your idea, and your what do you call, you focus on your idea, you focus on your what do you call a solution, and then you use AWS Lambda, deployed it. If people are using it, you pay. Otherwise you don't have to, right? So that is again a very good model for startups and those things. And again we are able to use this to fine tune our the code performance and adjust memory runtime. So most of those things will be done by the AWS automatically, right? So that is again one major advantage. So this is again like rapid response, right? You can the I mean, if there's an increased, the cloud provider will taken up the managing the capacity, right? So this again you have to apply a different flair of development, but but still it's a it once you have got into that mood, and then that behavior, that will be a very interesting, and that will be rapid development as well, right? So that will actually sometimes cut your effort, and that will help you in the long run. So then again, automatic scaling, load balancing, yeah, so all of these are very good things, right? So this will actually help you in uh, coming up with a good product, right? So serverless, the advantage of serverless is that. Okay. So assume, let's discuss that how a typical AWS Lambda work, right? So basically how it will work is that so basically we so example, assume that we have a website, right? So probably the front end code we will deploy it in S3 bucket, right? So now when a user clicks something, probably we can make a S3 call, and internally if there are any database calls, the front end has to make. What will happen is that it will go to a Amazon API gateway, API gateway, and you can either come some, like if it is required, you can use the API gateway as well, but otherwise you can just skip the API gateway. You can directly talk to Lambda as well, and then once the Lambda is invoked, it will run that particular code, And then once that you run that code, assume that part of the code is to contact a database and retrieve some data and send it to the front end. So then Lambda will do that work, right? So key thing to notice that uh, the Lambda will is just execute what you are asking Lambda to execute, nothing else, right? So basically, high levelly, I go to this website, I then website load with my what if it is in static codes are loading from S3, and I click something and it require going to running some backend code, then it will go to API gateway. From API gateway, it will identify the endpoint, it will invoke Lambda, and Lambda code will run, and then part of the code, I can connect to a database, get the data, and then show it in front end, right? So what this literally means is that this is the event driven architecture, right? So Lambda will always get triggered based on the event, right? So event can be anything, right? And it can be a user request, or it can be a system generated API call as well, right? So as there can be situations where you upload something into S3, and you can you can create a CloudWatch event. So whenever that S3 bucket some data is getting added, you can trigger CloudWatch alert, and then based on that you can connect and invoke a AWS Lambda function, right? So this is again like a totally event driven, right? So either if you want, like you have some scheduler jobs, right? Scheduled jobs running, you can use AWS Event Bridge, and then schedule something, and then let Event Bridge based on the schedule times invoke a Lambda function, and with that you can use this. So this is again very uh, easily invocable approach, right? So basically that's why a lot of people call this event driven Lambda as well. So this is example, like how we can use this for file processing, right? Assume that I actually take a photograph, right? And then I uh, uh, upload that photos into my S3 bucket. The moment that the photos are uploaded, I can ensure that there's a CloudWatch event trigger, and that goes and trigger Lambda function, and then Lambda will come and recite the code, and then upload it something, right? So one of the classic area use case, right? I can remember, right? Is that so when a picture is uploaded, we can get Lambda to create the thumbnails, right? So idea is that you upload the image, and the moment image is uploaded and your the website need thumbnails, Lambda can identify, then get it triggered, and then identify that image, and then run the code, create a thumbnail, stop, right? And then you can go and upload it to your server as well. So that way, like you can automate that entire thing, right? So this is again the beauty of Lambda, right? One thing I want you to remember is that it's serverless, right? Because of its serverless, it has a lot of advantages as well. So so with Lambda, like not everything is good, right? So there's a beautiful story to Lambda, which is like which is you don't have to worry about your infrastructure, and you don't have to worry about the capacity, you don't have to worry about scaling and those things, right? We are simply worrying the focus on the code, right? So that we can spend a lot of time and do the coding, and we are not focusing on what you call the upfront infrastructure cost. So we just simply deploy something, and we can actually go with the approach where we are only paying what we have been using, right? So those are good advantages. But what are the disadvantages? That sometimes we have seen when we are invoking Lambda, there can be some delay, right? Because the way we have configured, so we call it a cold start, where but there are some approaches, we can minimize that as well. And then there's the runtime is not unlimited, right? So AWS is sometimes defaultly putting some runtime threshold as well, because assuming that they don't want, like we are running a code, and we can easily use Lambda to create a some bad impact to AWS as well, right? I get I let it run something for ages, right? So that will even though I'm having the cost, I'm paying the cost, but it will have impact on AWS, right? So because of that, the runtime is limited, with changes and going to them, we can increase it, but it's not unlimited, right? In one of your servers, you deploy something, you have a not unlimited, but you have a full control of your execution time. But here it's limited, right? And plus, number of concurrent users are again limited, because if you create a account, newly account created, then the concurrent will be much less, right? Only once it's going through, you can increase it, but you can still contact AWS, and if you have a major business need, you can reach out to them, and based on your request, they can increase as well. So one of the other disadvantage of this approach is that there's a vendor lock, right? So probably we will do things in a little more AWS native way, and we will be stuck with AWS, right? That's sometimes what some uh, the clients think, right? So, but there are lot of ways you can do this without getting trapped into vendor, like so you can actually focus your code only, and make your code isolated, and then decouple it some of the Lambda, like the handler methods. So in that way, that you can still take the same code and uh, deploy it in your on-premise infrastructure or some other cloud provider or any place where you can minimize this vendor locking as well, right? So this is kind of like very high level overview of Lambda, and how, where we can use it, advantages, disadvantages. So any questions, anyone? Okay. So, so, so Lambda has a lot of use cases, right? So data processing, again, like, because this is event driven, we can let, we can let some events happening. Based on that, we can invoke our Lambda functions, and, so especially like, the data processing where you have your ETLs, right? Then which are doing your extractions, and, your, the processing, and then all your reporting and everything. So you can use Lambda to do this work, and save a lot of cost as well, and then it will be very efficient, right? Once you deploy serverless based approach for this data processing, then you can use a real-time file processing example which we discussed. So that is the use cases are endless, right? So that will actually go help you in wide array of use cases. So this is again good for backend for mobile web applications. So it's again event driven, so we can get the kind of like the we can whenever based on the user events, and then we can invoke our Lambda functions and then the backend calls, and get our work done, right? So this is again a very good approach, right? That will efficient and improve our development, and also the final output. So there are a lot of IoT, like uh, uh, data processing, which are using Lambda. Again, advantages. This is event driven, so we don't have. So the advantage coming up with event driven is that uh, like we don't. So we are. I mean, our service or our code is getting involved only when someone asks for it, right? When there was an event. Otherwise, we are not paying, right? So that's a one major advantage. And there are a lot of automations, right? So there are a lot of automation user cases where Lambda is being used, and that add lot of um, cost benefit and efficiencies to any of the solutions we are bringing, right? So very high level, that's what the Lambda is doing. So So example, if once you go to AWS console, you can go to Lambda. So here, like, you will see, like, you will see your, you can see the initial, the Lambda dashboard. And, so it will kind of give, so example, in my account, I have kind of I have three Lambda functions, right? And, my the store the code storage, so that they are like it's I'm getting around 750 GB, and so at the moment, because this is a kind of a new account, my the concurrency is 10, right? I so like it's very less, but I can go up to over 1,000, right? If I'm having a lot of hits, right? So again, like I can see that the what you call lot of invocation and other details as well. So area where the places where I like example I'm at the moment, I focus is this uh, the functions area. So here we can uh, create a function. So if I go and create a function, I can give a kind of a name. Let's say something, right? And then Lambda support, multiple languages, right? So you can go with either, C Sharp or, .NET version, or you can use Go, you can go with Java as well, Node.js, Python, Ruby. So all of these are supported as well. And, there are different versions of, example, Java and Python, it supports as well, right? We can pick up the architecture and we can, set the permissions, right? So example, if you are accessing our Lambda is accessing some of the like services like RDS and those things, we will have to grant permissions accordingly as well. So it will have kind of like uh, uh, the advanced settings also we can enable. So this account I have issue where some reason I'm not able to see the code, right? So this is one of the hello world example, I have put initially, but some reason like the with the security settings, I'm not able to see the code. So this code is something like this. It's a very simple. Let me get the code. In some reason I have not copied. Just give me 1 second. I'm just checking for that code. So the idea is that so we will simply write our code and then forget about anything else. Right? So that's the beauty of the Lambda. So, so I have done like just for this session, like very few examples where let me just get that. Got it. So, share my screen again. So let me share my screen again. Hope you are able to see. So it's kind of like a very simple code, right? Just like in any other language, like, if you written kind of like a code. So here, like, we are using Python. So we are simply, calling this Lambda handler function, and we are printing something called hello world, and, with the JSON dump. So here idea is that, so example, once I create something, I will get a view like this, where I can, go and generally speaking, like, if you have the security permissions allowed in your browser, like, you will able to, update the code and do everything in this area. But otherwise, you can upload a zip file, right, from your machine, or you can put something in S3 and then, run your code as well, right? So basically, like, here now example, if you see, I have this, so there's not very, it's a very just simple thing. So when I make it, you will see that, it's print hello world. It's a, not a like a very big thing, which we can do that, and assume that, so here again, if I go back, I have, what I have done is, like, for uh, the work purposes, whenever I created whenever I created this, what do you call, my code, I am uploading my codes into the S3 bucket. So I created, like, and they are, like, I have this hello world, the Lambda zip files, right? So I have something called Slack and Lambda function. So these are actually, like, so once I created this, I can go back to Lambda, and from there, once I have created a new function, I can simply call them. That's an example. Assume that, okay, let's go back to that S3. We'll get, I'm not too sure what is this Slack clam. So let me just, let's take this one. Okay, let's go to bucket again. So basically what I'll do is, I'll go inside. I will take a copy of the URL, right? And then I go to Lambda again. And so here, let us create something. So it's easy. You can simply create a function. You give a demo Lambda, and here I will select, this is Python, and I'll not change anything. I'll just create a function. It will take a short time, and then I see now my function, all the data is available. So again, like, this is some issue with my machine, like, I'm not able to see the code. So what I'll do is, now I can go to my S3 location, like, I'll tell, take this zip file. So now it uploaded. So I will, so in, usual case, you will see the code, you will see file window, all your file system, everything. And then after that, you can kind of, test this. So this is failing because I have issue somewhere. Okay. no module name Lambda function. So because like probably I would have taken a different handler name. They are again, I can't remember which one, but let's see, know some other. Okay, this is one Slack test. Code is coming. Let me. Okay, I'm not able to let me go test. So this one is working. So if everything goes well, you will see, and you can go into the logs and get details as well. So here it says like message sent successful to Slack. So let me check whether you are able. Let me um, new share my Slack channel. Yeah. Slack. Stop the share. Let me log into the Slack and come back shortly. Okay, sorry, I have my Slack channel. Let me. So let me load my Slack channel. Just give 1 second. Yeah, I'll resume my sharing. And so basically, uh, yeah, the share option. Share. Slack channel is not. Okay, yeah. Yes, the Slack channel. So idea is that, so this is a small program, just for the testing we are doing. Idea is that, so if you see like, 746 from our, what do you call this, the Lambda, we are actually sending a message to a Slack channel, right? So if I want to show you that code, right, what is that code again? Let me go back to our PowerPoint. Here, it's a simple code. So what we are doing is basically, yeah. So what we are doing is actually we are importing the JSON and we have the request. So and then we are getting the Slack work URL, and then I have kind of a message, and then kind of like I like use this Slack the way it is supposed to send the data. I set in the headers and all. I'm simply sending the data. So here let me go back again to um, sharing option AWS. So here, so the code section, you will see the code, and then there are quite a few things, we can set, such as, the properties and other things, the runtime, right? So sometimes, like example, some of the instance, some runtimes are not working. Like, you will have to add and edit and add the Python version, those things. So these are kind of like, the changes you are able to do. And under configuration, there are a lot of general configurations, which we can do, and that we can change the trigger, enable triggers, and we can work on the permissions aspect as well. So, so likewise, so there are a lot of options, which are provided by AWS, which will help you, going and uh, getting this facility, right? So again, and when it comes to monitoring, there are load of you know you can see number of invocations, the durations and errors if there are, right? And the throttling, whether so there's only one, right? In this account, there's hardly any concurrent hits happening, but all those everything, uh, the observability piece is here. It's inbuilt part of uh, the Lambda, right? So what I'm suggesting is that with this knowledge, you go to generally to Lambda, that you try to like very easily you can find the code related to a hello world in any language, right? You copy that and try to create a small hello world and run it. So assuming if it is running it, the second I the step is you create a RDS database and then create a small table there, and then have a Lambda which will talk to your the database RDS, like AWS RDS, and pull and display that data, right? So there you will see that there will be a lot of issues happening. You will have to enable access, right? So you will learn a lot of good things about what to enable, what level of access you have to enable. And then when you are creating the code, you will have to use some Python libraries, request, right? So they are like you will have to probably. Then what I have done is for the testing, I went to a particular EC2. From there I create a kind of like a directory, and there I run the the install commands to enable the request and other things. And that way that I kind of like have the entire package, right? So probably I can just show you that as well, if that EC2 is up and running. I don't think the EC2 is up, but let me check that. That is probably experiencing. But anyway, I think the approach is very easy. So you just go and create uh, instantancy. Probably with this you can get through, right? Unless you need some some like very important libraries and those things, you will not need that to use any of this the creation of environments and dependencies and those things. So it will work, and we also have the AWS also providing very useful blueprints as well, which is again example, the hello world microservices, and there are so many things which those are kind of like a readily available you know the blueprints where you can just simply use, customize, and then get your work done, right? So so with that we will finish this session. So whole idea is that wanted to give you a quick overview of AWS Lambda, fact that why serverless is important, the fact that you will simply focus on the code only, and you will focus on the development of this code, and then you will not worry about where to deploy. So it's simply that once I created the function, so I can create the applications as well. I will actually simply deploy this code, right? The source code here, and then matter of running, right? So after that I'm not going to worry that where, how it is deployed, and how AWS is taking care of that, and I'm getting billed only for this number of invocations. So yeah, so that's it. Any questions, anyone, before we move to the next session?